All right, so 3C is the solving the equation problem, one of them. So guys, what's weird to me is if I ask you to like simplify, what would you do here if I asked you to simplify this? If I ask you to simplify this, what would you do? Distribute. And what do you get? And then what do you do? Like terms. So you get, and that would be it, right? You guys with me? I like it. Some of you guys are like, what the hell's that got to do with this? Well, because the first step in solving an equation is that you look at each side on its own and you simplify each side first. A lot of you guys treat equations like they're something completely different. They're really just two sets of this kind of problem set equal to each other. That's all they are. I'm sorry. You're good? So what would I do on this side? So you like cover this side up. What do I do here? Yeah. So here's, I got to distribute first. Almost always you distribute first. So you free everybody up. So you bring the negative 2 in. And this, of course, is where people make a big mistake. I like the way you said it. It is a negative 2, right? Yes. So I got 3. Negative 2 times x is negative 2x. Negative 2 times negative 5 is positive 10. That's the big mistake people make. There was a problem on the test that was like that. Let me stop there for a second. Is everybody so far so good? And there's that little +1 just hanging out. Now look on this side. What can I do on this side? Again, distribute. See, so I don't worry about the two sides interacting at first. I don't have to worry about that at all. I just simplify this side, simplify that side until I can't simplify anymore, and then I start moving stuff around. Some of you guys treat it like it's something else entirely, but no, that's all it is to begin with. Simplification. Of course, what can I do on this side? What's the only thing that's not like on this side? So everything else I can put together.
Okay. So you can put it on first.
No, you just put them together. What's 3 plus 10 plus 1? 14. What else is over there? And over here I got just 6x plus 8 hanging out because there wasn't really much to do on that side. So you almost always get to a point, numbers and x's on both sides, and this is where you just pick a way to go. Now thankfully not a lot of people are doing this. This is, let me see. If you're writing this down, stop for a minute. I'm going to make a mistake and I don't want you to write it down. I'm not going to make a mistake because I feel like I'm going to make a mistake on purpose. So I'll have somebody do this. I mean, whoa, holy shit. I don't know if you guys are following what's happening. I just moved everything on that one side. And normally, actually, what happens is this kind of thing. It's just, wait a minute. So, that's a big mistake. I don't know if you see what that is, a mistake. Because what's the idea? I want to get x's on one side, numbers on the other side. Right? So there's a lot of this kind of like, just jam stuff together. And sometimes, here's another mistake I see. Sometimes I'll see this. I'll see, what did this person do? Can you guys tell what this person did? Be a teacher for a second. Try to figure out what this person did.
They added the
14 and 8 is 22. Negative 2 plus 6 is 4. How the hell did they go across this divide? I don't know. They're like, that's what I can do. No. My math is strong. No. Your math is weak. So what's the right way to do this? Yes.
Negative plus 2x.
Yeah, you can add 2x. I like it. So move the x's that way,
Correct.
which means I want to move the numbers the other
The
way.
other way. Minus
So I want to take this 8 and make it go away. I got all my x's on this side. I'm going to let all my numbers go to the other side. So I moved my x's this way, made them cancel there. Moved my numbers this way, made them cancel there. Does everybody see what I mean when I say move my stuff around? I mean, I make it cancel on one side and I move it to the other. So now I get 6 equals 8x divided by 8, divided by 8. Yeah. X is equal to what's this? Which is? Reduce it? Reduce it? Sorry.
Over 2. Hang on.
3 over 4.
3 over 4. Okay, let me stop for a second. Some of you guys are being really mean to yourselves. Math is hard enough already, but some of you guys are not writing everything for yourself and trying to guess where things end up. There should be no guessing. There's no guessing. You just bring everything with you so you don't put stuff in the wrong place. I think you're trying to save time by not writing as much, but you're very quickly getting to the wrong answer. That's not good. I'd rather kind of slowly get to the right answer. That's better. I can't. Oh, go ahead.
You done with that?
Oh, yeah.
Okay, can you simplify an answer, something like 4C?
Oh, what's the difference between, if I wrote, so 4C looks like this. This one right, or are you talking about from the test?
That's from the test.
Oh, I'm sorry, I'm looking at the practice one. Alright, let me see.
Who won from the test?
Where's my, let me steal somebody's test. Here we go. Oh, is this the one about determine if the point is the solution?
No, it just says simplify. It's 12 over 35.
Oh.
7
All
over
right,
20.
so it is from the practice fund.
Yeah.
Okay. I thought you meant from the test we just took. So 12 over 35 times. Now there's something I can do there that if I wrote it like this, I could not do. What can I do here?
Reduce.
Yeah, I can reduce. Why can I not do that here? So I see people doing this on this kind of problem. I see somebody do this. All right, that makes no sense. That makes no sense. What are the operations? This is division. This is addition. Are they opposites? Are they opposites? Division and addition. Are division and addition opposites? What is the opposite of division? Multiplication, right? So are division and addition opposites? So can they cancel each other? No. So if you're trying to cancel something, you step back and say, are the operations involved opposites? If they're not, you can't cancel this. So this one I have to get LCD. Too bad for you. I can't make the numbers smaller because they're not multiplying. Here, oh sweet, they're multiplying. Multiplication is the opposite of division. So that's why I can cancel stuff, because that's opposite operations. So sure enough, 7 goes into 7 once, 5 times. What goes into those? 4. 4 goes into 12, 3. 4 goes into 25 times. Do you have to do this reducing first? No. But hell yes, I want to make my numbers smaller first instead of making them huge and then trying to reduce that.
Yeah, that's what I did.
So then, what do you get then? 3 over 25. I like it. I like it. Yes.
Number 6.
On the practice final?
Yes.
What about it?
Well, I don't know how to do the fraction or decimal.
From fraction to decimal?
Or to the words into decimal percent. Right.
Well, so everything. Okay. All right, that's a very large question. Let me see. Let's take that piece by piece here. So if I have 1.4%, what is that as a decimal? What's-
0.1.
Yeah, you move it back twice, right? And again, remember, from decimal to percent, you move it that way. From percent to decimal, you move it that way. I'm going from percent to decimal, and move it back. Why is it always twice? Because percent means per 100. 100's got 2 zeros in it. So I'll move it once, twice, so it'll be 0.014.
So you have to put 0.
You don't have to put this 0, but it's good to do it so that little decimal point doesn't get lost.
What about fraction?
And then what is this as a fraction? Tenths, hundredths, thousandths. 14 thousandths. I like it. Now, you don't have to do this, but for those of you who kind of see what I mean, percent means over 100, right? But why is this not acceptable as an answer for a fraction? Because it's not really a fraction. It's a fractional or a decision. It's an inception fraction decimal thing, right? But remember what I said, if you multiply the top by 10, you multiply the bottom by 10, holy shit, got the same answer, yay. So that's another kind of clever way to do it. Or you just make it a decimal and go right to fraction. Every decimal you can go right to fraction.
Can
Yeah.
you do a different example by using the second one?
Well, if I had 0.02%, that's 0.02 over 100, right?
Yes.
Once, twice, 2 over 10,000. Bam.
It's easy example.
I know, but I don't want to force you to do that if it doesn't really make sense. But if it makes sense, it's a great way to do it. There's so many ways to look at any specific problem. What you guys have to realize, and why people have trouble with math, is they don't realize that they can make it their own. There are multiple ways of looking at it. So certain teachers teach math early in your career, and they say you must do it this way, and it's just not the way that jives with you, and you hate math, and that sucks. That's stupid. There are so many other ways to do mathematics, and certain teachers have to be more flexible, and then more students would come into it.
What about more like 13 over like 25 or something like that into like a decimal?
If you don't see the shortcut, you can always just do the operation this represents, right? What operation is this? Division.
Yeah.
This is 13 divided by 25. You could do that. I would much rather look to make the bottom become what number that relates to percentages? Hundreds, right? Now real quick, you guys help me out. 11 over 100 is what percent? 11%, right? There's no easier question than that because per 100 is percent. So 9 per 100 is what percent? 9. Oh my God. So if I can make the bottom become 100 easily, yes, I will. Right? Do you guys see? Because then it just becomes a percent directly. So how do I make the bottom become 100? Multiply by 4. Right? What times 25 is 104?
100.
So the bottom I get 100 like I want to. On the top I get 52. So what percentage is it?
52%.
52%. So see on the answer key where I say 13 25ths? 13 25ths?
Yeah.
If you do this first and you say 52 hundredths, I'll accept that too, because it's the same fraction. So if you rewrite the fraction and then put it in words, that's fine. Nothing wrong with that. It's the same fraction. So you say 52 hundredths if you don't like saying 13 25ths. Ruth's Chris Steakhouse. Yes.
So when you write it in like the word form, you're supposed to like, how does it just write it?
The list. The fifths. Right? The fifths. So this would be 13 25ths. This would be 52 hundredths. Right? Right? Is everybody cool with that? Because 52 hundredths is 5,200. That's a bit larger than this. This is 52 hundredths. The THS makes it into a part per hundred. So that's what that really means.
Can you do?
Oh, okay. All right. So Davis wants to take us into conversion problems. Were there any other questions about this type of problem? Is that this type of problem okay?
So a fraction, you just do the opposite.
Oh, the decimal to a fraction is anything that's written as a decimal. You can take it directly to a fraction. You just have to figure out what place it's in. So what place is that in? Tenths, hundreds, thousands, 10,000s, 100,000s. So it'll be 11, 100, thousands. Now the shortcut, I think you heard. Some of you guys might remember this. 1, 2, 3, 4, 5. So 5 zeros. Instead of going tenths, hundreds, thousands, developing a list. Yeah, exactly. I didn't used to have a list.
For number 1, why don't you like go beyond like -4 b plus 1? Like why don't you like
Where am I at? Sorry?
1k?
1K. Okay.
Number 1k.
Yes?
Why like you don't just go beyond like +4 and +4? And can you just do it?
Why positive 4? 2 minus 6 is not positive 4. So 2b minus 8 minus 6b plus 9. What is 2b minus 6b?
-4.
Negative 4b, yeah?
Okay.
And what's negative 8 plus 9?
+1. Okay, why don't you and I like just go beyond and do +1, +4?
I don't understand. What tells me, how can I go any further? What is it?
This one.
No, it's okay. I want to understand.
So just I'm saying that you write 4 under -4, +4 under -4, and then +4.
All right, so many things.
It's because it doesn't have a
So many things. No, so many. Because a lot of people are doing stuff like that. Two main
Just
things.
get b like alone and
There's no equation, so there's no other side to do this to. And adding cannot cancel multiplication. So if this was an equation, I couldn't add 4 and cancel this -4 because it's timesing, so I have to divide by it to kill it, right? And there is no equation, so there's nowhere to move it to. Cool, I like it. But no, I'm not coming down on you. A lot of people do the same kind of mistakes. That's why I wanted you to go further, because I knew where you were going. Okay?
I was gonna say, could you do 4 Bravo, please?
Oh, well, all right. Let's get into fractions here in a minute. I want to come back. Davis asked a little while ago for conversions. And actually, for the most part, a decent number of people got the conversion stuff decently well. Either it did well, or it was completely not understood. There was barely anything in the middle. So, yes, sir.
Why did I don't want as a because I think
Fractions.
yes,
Oh, I see. All right. So, on the final exam, of course, I'll give you all the conversions you're going to need again. It is possible I'll give you a different set of conversions because the process of conversions doesn't care what you're doing. So if I said 1 foot equals 30.48 centimeters. And how many feet is in a yard? 3. So let's say I have, it doesn't matter. Let's say I have 92 centimeters of something, and I want to know how many yards that is. 92 centimeters, I want to know how many yards that is. Yeah, so where can I go? I can go from centimeters, I can go to feet, and then from feet, I can go to yards. I like it. So where do you put centimeters here? Down here, so they'll cancel. From centimeters to feet, and then from feet to yards. So where do I put feet? So now you put in the numbers where they're supposed to go. Some, we're just throwing the number just wherever they want to, but where's that 30.48 have to go? Because it's centimeters. 30.48 of these in one of those. And then how many feet, how many yards? 3 feet for every 1 yard. There's a definite place they go. That's the beauty of putting the unit first, because then you know exactly where to put the numbers. You put the numbers with the right unit. And now you just do what this says to do. What does it say to do? 92 divided by 30.48 divided by 3. That's exactly how you can put it in your calculator.
Oh, you divide them separately.
Well, you're going to do it all at once. You can do, in your calculator, you put 92 divided by 30.48 divided by 3. It's like 1 point something. 1.0069?
Yeah, 6.1.
Like 6. Yeah, so I started in centimeters. So I put the centimeters there so they would cancel. Yeah, so 30.48 centimeters for every foot. And then 3 feet for every yard. See it? Alright, let's do note.
That's why I can't.
So if you got 7.2 yards, and you want to know how many centimeters that is, how can I get to centimeters from yards? I can go from yards to feet, and then feet to centimeters. So where do I want to put yards? On the top or on the bottom? On the bottom, so that they'll cancel. So I go from yards to feet. And then where can I put feet? On the bottom again, feet to centimeters, so the feet will cancel. And now I just fill in the numbers in the right place. Feet and yards, there are 3 feet and 1 yard. So 3 with the feet, 1 with the yard. Centimeters to feet, there are 30.48 centimeters for every 1 foot. Yeah, so it's all about how do you make those units cancel so you can replace them with different units. So to make the yards cancel, you got to put the yards there. Yards to feet.
Okay, so now we got all that on the top, right?
So what I'm going to do what with all those numbers?
Multiply.
Multiply all of them.
And then come over to centimeters.
So it kind of makes sense. See, on this one, I started with centimeters,
Right.
and I wanted to go to yards. I ended up dividing. So if I go the other way, start with yards to go to centimeters, I'm gonna multiply. That's why that's the change. That's where the units end up is where the numbers go. That's it. There's no guessing at all with this. Okay, maybe. I appreciate the fact that I think about 6 people got that one bonus with the Meeblarks and the Zeptons and stuff. Yeah, it's bonus. I can do whatever I want to with bonus. That one actually wasn't too crazy if you just got past the words and just set it up like this. I mean, why do we call this yards? Because Frank Yard made it, I don't know. Probably Frank Yard. He did a lot of shit. We could have, who knows, it could have been called Ooblots. And nowadays we could be going, no, not even thinking about it. 2nd and 3, they got 7 yards to the goal line and 7 Ooblots to the goal line. We wouldn't think twice. Yes? Please make me stop. 3B.
I don't know how to like put the X's together and how they do it.
That's the one on the practice final?
Yeah.
How did you get 12 on the same one? How did you get 12 for the second one? The 3 over.
What's that? I'm sorry?
The same one. How did you get 12 on the second one?
Okay. Oh, that's fine. He's asking the same thing. Alright. What's up? Oh, I had like 3 people talking to me, so it's hard. So it starts off like this. Now what's funny to me is I know that when I have fractions, very often I'm going to have to find an LCD. So here's an equation with fractions in it. It's got addition happening, all kinds of stuff. I'm hoping that kind of spurs your memory. Oh yeah, I've got to get the LCD first. But why, in this case, do I want the LCD? Why? Because if I make all of these bottoms 18, everything is being divided by 18, so then I'm allowed to go ahead and multiply by 18 and kill all the bottoms. All right, here we go. So how do I make this become 18? Multiply by 6. That's where the 12 comes from. How do I make 9 become 18? Multiply by 2. Rick is quick. You gotta watch out. So now I get 5x over 18 plus 12 over 18 equals 2x over 18. What's beautiful about equations is you're allowed to do things to it that you're not allowed to do if it's not an equation, because I have 2 sides to balance out. I hate those freaking over 18s. I hate them. Kill them. I'm allowed to kill them. I can kill them. What do I do to both sides to kill them? This is divided by 18, so I'm going to multiply by 18. And what I end up doing normally is I would distribute this, so I just write it next to each piece, so I don't forget. So if you make all the bottoms the same first, you can then kill them all.
5x plus 12.
Yeah, 5x plus 12.
And then add x's together.
Well, now you just solve like normal. Part of your brain says, oh, this is different. No, I did shit to make it the same. Now it's the same old thing as always. Nothing special about this equation. How do I solve this equation? What's in the wrong place? The 5x is in the wrong place. So I just subtract 5x. See, I think that's another part of it too. You guys have to realize the minute you do something to an equation, it's not different, but it looks different. And then you can just work with the way it looks now. So I know it used to have fractions, but it doesn't anymore. So just now, if I gave you this problem, you should hopefully go, oh, thank God, I can do this. Yeah.
So I think you should subtract it. So how do you get negative 12? Like, will come out 3x equals negative 12. How's that negative 12?
All right, so what I did I? Okay, so I just do what I always do, which is keep the x's. So I subtract the 2x and subtract the 12. Who cares? I really want you to understand. Who cares which way you go? Something is going to be negative, so at the end your answer is going to be negative. So let's do it the way we would do it right now. What would you guys do? Like you said, the 5x is in the wrong place, so what would you do?
Take away your
Take away 5x.
Oh, you took away 5x.
No, I didn't, but we are right now. So then I get 12 equals, and then what do you do?
Divide by 3.
Divide by negative 3. So you get x is
4. Negative 4.
negative 4.
4. Negative 4.
Is that the answer I got?
Yeah, just wrote different.
I know,
Just do it.
but I desperately want you to understand, I don't care if the 12 is negative and the 3 is positive. If you choose a different way to do a problem, it's not going to look the same as somebody else's in the middle, but it will look the same at the end.
So you wouldn't do minus 2x from 5x, right?
That's what I did. I just got to do that in my head. You got to excuse me, I'm sorry. I just I subtract 2x, subtract 12, just to keep my x's positive. What's up? Okay? But I mean, that's what I did, just to let you know. But I mean, we should know this by now, that if I ask you to factor 18, and you do this, but the person next to you did this, right? It's still going to come out to the same at the end. So in the middle, yours doesn't have to look like anybody else's if you chose a different way to do it. As long as at the end we agree.